This is video number 14 in my series on Foundations of Arithmetic, Algebra, and Graphing. My name is Bill Kinney. The last couple videos have been the start of my sub-series on the Arithmetic of Rational Numbers. This is part 3 of that sub-series. Rational numbers is the official name for what people often refer to as fractions. In the last video, we looked at a situation where we had two people, Greg and Marcia, who could paint a certain room in different amounts of time. Greg took 6 hours to paint the room, and Marcia could do it in 4. First thing I want to point out about that in this new video is that, this is a point of confusion for many people. 6 certainly is bigger than 4, but 1/6 is less than 1/4. Basic fundamental thing to know about fractions, and if you think about it, it makes sense. Think about the pictures over here. The 1/6 of the room is smaller than the 1/4 of the room. Marcia could paint faster than Greg did because it didn't take her as long. It's a little confusing, but that's true. A basic fundamental thing that people often get mixed up about with fractions. When you take 1 divided by a bigger number, that ends up being smaller than 1 divided by a smaller positive number. Let's finish this problem. In the last video we answered how much can they do in 1 hour if they work together? How much can they do in 2 hours? The answers were 5/12 of the room in 1 hour. 1/4 plus 1/6 was 5/12. That's here. If I add 5/12 plus 5/12, I get how much can be done in 2 hours, which was 5/6. Right there. And that is the same as 2 times 5/12. 2 times 5/12 should mean, we would want it to mean, 5/12 added to itself twice. Or added to itself once, I guess I should say. There's two 5/12s there. Let's answer the last question now. How long will it take them to finish? After 2 hours, they don't quite finish. Notice that. After 2 hours, they're almost finished, but not quite. 5/6. They've got another 1/6 of the room left. How long is it going to take them to finish that 1/6 of a room? This is a bit tricky. Oops. If you recall what I said about multiplication here, it can help. This is going to be sort of an algebra problem too. Ultimately, we're going to define multiplication of two rational numbers, two fractions where the numerator and the denominator are both integers, as being what you get a new fraction when you multiply the numerators individually. 2 times 5 is 10, and you multiply the denominators individually. 1 times 12 is 12, which then can sometimes be reduced, as it can in this case, to 5/6. I will say that, by the way, you also can do some what's called cancellation here initially to get 5/6 right away after you do the multiplication. You can cancel the 2 with the 12 and think of it as 1 times 5/6 right off the bat. Either way you do it is fine, but that is how you multiply fractions in general. You multiply the numerators individually and you multiply the denominators individually. And I'm trying to say that the rule makes sense based on thinking about examples like this. But that rule generalizes. And so the key to solving the last question, how long will it take for them to finish, is to ask, what do I need to multiply, there's a question mark here, 5/12 by to get 1? Does that make sense? Back down here again, the 2 there represented a number of hours, really. They could paint 5/12 of a room together when they work together in 1 hour, times 2 hours. That means in the end they painted 5/6 of the room. The answer is going to be a little more than 2 hours. There's going to be some number I'm going to be able to multiply 5/12 by. It's going to be a little bit bigger than 2 to get 1, to get a whole room. 1 room. A little bit of guessing here. That's the way I'm going to treat it here initially. In maybe the next video we won't focus so much on guessing. What do I need to multiply 5/12 by to get 1? And if you think about what I did here, multiply the numerators and denominators, maybe I should think of it as a fraction, question mark over question mark. What I want in the end to get 1 when I reduce the fraction is I want the numerators and denominators to be the same. And if you think about it a little longer, you realize that if you make the top question mark 12 and the bottom question mark 5, that's going to do it. 12 times 5 is 60. 5 times 12 is 60. 60 over 60 is equivalent to 1 over 1, or just 1. The answer is going to be 12/5 hours. That's how long it's going to take them to paint the room completely when they work together. 12/5 hours as an improper fraction where the numerator is bigger than the denominator. If you wrote that as a mixed fraction, think of it as 10/5 plus 2/5, or 2 plus 2/5, 2 and 2/5 hours. That'll be the answer. Now 1/5 of an hour, think about that. 1/5 times 60 is 12 minutes. I'll let you think about that. So 2/5 of an hour is 24 minutes. This is 2 hours and 24 minutes. That's how long it'll take them if they work together. Of course, in all this, there's an implied assumption that I'm assuming they're estimates back up here. I did say estimates, or accurate, which they might not be, but we're pretending for the sake of getting an answer. Got some more questions here. We're running low on time here for this video, but let's see if we can at least answer the first one, and I'll let you think about the other ones in the next video. I'll start there. In the context of Greg and Marcia painting the room, the last problem where Greg takes 6 hours and Marcia takes 4, how much of the room can they each individually paint in 40 minutes, 45 minutes, and when they work together for these times? So let's focus on the 40 minutes. How much of the room can Greg paint in 40 minutes? Well, again, here's Greg's picture. He can paint 1/6 of the room in 1 hour. 40 minutes is 2/3 of an hour. If I broke up this one part of the room that he can do in 1 hour into 3 equal pieces, and just pretend those are equal pieces, 40 is 2/3 of an hour. 40 divided by 60, 40/60ths is 2/3. Think about that. It's going to be those 2 sections that he paints out of how many total? How many total small sections like that are there? Well, there's 6 big sections, 1, 2, 3, 4, 5, 6, and to split all those up into the same size sections as these, there'd have to be 6 times 3 of them, 18 of them. Looks to me like Greg can do 2/18, or 1/9 of the room in 40 minutes. That can be represented as a multiplication. What multiplication? 2/3 times 1/6. This is the fraction of the room that he can do in 1 hour. 2/3 is really the number of hours. Thinking of the hours is canceling here. Multiply the numerators. 2 times 1 is 2. 3 times 6 is 18 for the product of the denominators, and you get 2/18, which is equivalent to 1/9 of the room. That's how much he can do in 40 minutes, 1/9 of the room. Thought of another way, there are 9 40-minute periods in 6 hours. 1, 2, 3, 4, 5, 6. There's another way to think about what that means, and I'll stop the video there.